So you've just bought your first STM32 Nucleo board and you don't really know what to do with it. So I'm going to hopefully give you a rough idea of how to get started within this video. So there are a few prerequisites before we begin. First of all, you need an STM or an ST account. So this is ST Micro. So if you just look up STM32, you need that account. You also need STM32 Cube IDE. You need the ST-Link board firmware upgrade. So this is software that will just upgrade your debugger, which is built onto your board. And you need to go and find your dev board page on ST. So the way I did this was I just looked up STM32 Nucleo F33 4R8. The reason you need to find this as well is because it's handy to know what pins are connected where. So if you go to the CAD resources here and download the schematic, it doesn't really matter which one, probably the latest one preferably is the best one, and then you need to download and install STM32 Cube IDE. So let's do that now. So whenever you get onto this page, if you go down, so if you just click get latest and download that, it's going to ask you to accept some stuff. This is why you need to sign in, because it'll ask you to sign in anyway. So if you just accept this and it'll start downloading, and then whenever that is done, or while it's downloading, doesn't really matter. So get latest, accept, and it'll download. So once you have those downloaded, first thing to do is plug in your board and then extract the ST-Link upgrade tools, and then go to the operating system that you're on. So other platforms, I'm on Windows, and if you click ST-Link upgrade and device connect, yeah, so if you just click device connect, it should find it. If it doesn't find it, plug it out and plug it back in, and if that doesn't work, then I don't really know, because I haven't encountered any other issues. If you're doing this through a VM, there will be a problem with the way the VM sees the device. So it tries to put it into bootloader mode whenever you're upgrading the firmware or connecting to it, so that could be an issue as well. So once it's connected, you can just click yes and it'll go ahead and upgrade it. And then from here, when this is done, we can install STM Cube IDE. So STM Cube IDE comes with a built-in IDE and CubeMX. So CubeMX is their tool which basically allows you to generate a hardware abstraction layer for your code, and it just makes it easier to set up and program embedded systems using this. So if I just extract all for the ST Cube IDE, and then once that's done, just go ahead and install it. There's nothing that needs to be changed whenever you install this, so just keep everything default in the settings. So yep, next, you agree, yep, next, yep, you want to install these. So these are just drivers for the debugger. Install them, and it'll go ahead and install them. And while it's installing them, it'll ask you like extra stuff. Do you want to install this driver? Like Windows will ask you, are you sure you want to install this driver? And then you just click yes. So then once that's done, if you just hit next, doesn't really matter if you create a desktop shortcut or not, just hit finish. And then I must have had those drivers already installed because it didn't ask me. But if we go and try and run with STM Cube IDE, it'll maybe ask me whenever I go and try and program the board. Can't remember. Don't know why it didn't pop up there. It does on a clean install, it'll ask you about those drivers. So whenever this is installed, if you open up the window, what you'll need to do is log in as well here, because you need to download some extra stuff. ST have just monopolized their shit and make you log into everything now. So if you just do that and you hit login, it should just let you log in and you should be good to go. Authentication complete. Fantastic. Okay, now we've got everything set up. What we can now begin to do is create our project. So if you go over here, if this window, this information center isn't here, if you just go up and click new and then new STM32 project, and as you see, it's going to download some extra stuff, and it'll open, first thing it'll open is CubeMX, and then I can show you why using this is probably a bit better. Oh, okay, we need to actually select our board, forgot about that. So yeah, it'll give you this extra pop-up window, and then what you can do is select from here your microchip. So it's taking ages to load for me. I think it's because I'm recording at the same time. So if you go into this commercial part number, and then if you type in the number of your Nucleo board, so I know mine is F334 R8, so it's this one for me, and then it'll give you, it has the potential to give you 2 different chips with 2 extra part numbers. So if you put in like if you put in the part number of the microcontroller in here, it'll give you a couple of different ones. You just have to go off the one that your microcontroller is based off. For my case, it's just give me this Nucleo board. So this is the one I'm running right now. So yeah, if you just click next off that, and then it'll ask you to name your project. You can keep everything here the same, and then I'm just gonna call this Hello World. So Hello World in the embedded space is just blink. It's just blinking an LED. So let's just call it Hello World blink. So if you untick this, it'll let you select where you want to save it. It doesn't really matter for me. I'm just going to save it here. You might want to save it somewhere else. That's fine. If you go ahead and just select where you want to save it, I'm going to keep mine the default. I don't think there is a next. There is. You don't really need to go to this next bit. You can just click finish from here, from this point. And then because let's put this in a dark mode for me. It's just going to be a bit of a nightmare if you're looking at this, so I might have to switch it. Initialize all peripherals in the default mode, yes. A device configuration tool, so this is going to launch CubeMX, so you just hit yes. So whenever you hit yes, it's going to download some extra stuff, and this is just for your board. So what this has done is it's went and basically cloned out the default project, I think, because I selected the Nucleo board. So what I'm gonna do is get rid of all this for now if I can, and then it should come to a point where it'll be the same for you guys as it was for me. So you might end up with those pins all selected, which is just the like default program that the Nucleo board comes with. I must have just pulled it from their site. You may also only have your Hello World blink.ioc file here, or whatever you've called it here. That'll probably be the only folder, which is fine. You'll get all these other folders in a bit. So what we want to do is create the Hello World for embedded systems, which is just the blink. I was able to see here that my LED was selected, like the built-in LED, but that really didn't help me out, because whenever I did this before, I didn't have this selected. So this is why you need your schematic downloaded. So if you've went and got your schematic, it's probably open already. If it's not, it doesn't really matter, just find it and open it. And then what you can do is you can see all the components on the board. So if you come down, you can see the microcontroller. You'll also be able to see the different pins and the headers. So see these connectors, it says connector Arduino. So these are basically like the same sort of layout as the Arduino board, the Arduino Uno board. And I know that my built-in LED is LD2, which is the green one. But you should know this because it is the LED that should flash or behave in a certain way whenever you plug in your board, because they all come with like a default program. So I know it's LD2 for me, so all I need to do is follow this trace, and if I go up here it says D13. So D13 is the Arduino pin, but I'm looking for PA5, and I know I'm looking for PA5 because I've done this before. But also you'll end up looking and seeing, oh, there's 2 of these and I don't know what these 2 mean. So this is a pin on the board, this PB13, and this PA5 is a pin on the board. But if you look here, it'll say SP20, 24 and 29 close only for the F32R8. So if they're only closed for this board, then they'll be open on my board. So I know that it's going to be this pin. And if it's not, you could just try and Google it as well. So like there will be other people who will have tutorials for these things, and you're not cheating by googling. I always used to think that I was cheating by googling because it meant that I didn't know anything, but it doesn't really matter if you Google it or not. Like, the point is getting it working. So that was a long way of finding out and saying that my built-in LED, the green LED, is in PA5. So if I go back to my cube IDE and I go down to pin 5 and pin A5 and click it, so it'll give you a lot of options here, and these are all different. They're all peripherals or operations that this pin can do. So it can, I believe that's a digital to analog converter. I've never used that. It's an ADC, which is analog to digital. It can do that. SPI1, so serial peripheral interface. One, it's the clock of it. It can perform timer operations. It can read the GPIO as an input, GPIO as an output, GPIO analog. I don't know what the difference is between the analog and the ADC, if I'm honest. It could be the same thing. I don't know. It can also act as an interrupt, and then event out. I've never used before. I don't know what that is. So out of all these, it's kind of overwhelming, but I know what I'm looking for is GPIO out. So GPIO is general purpose input output, and yeah, I just want it to be an output because it's going to drive the LED. So if I just click GPIO output, and it'll select it and it'll be green. It'll also give it a name, so GPIO output, but we can change that. So if you right click on it and enter user label and just type green LED or whatever color the LED is on yours, you can call it whatever you want. I'm just going to call it green LED for my purpose. So if you've only had this file over here this whole time and these other files didn't appear, they will appear now. So what you need to do is hit this like cog, which is basically, it'll generate the code. So what it does is it goes and generates the hardware abstraction layers, which is basically code to stop you having the right individual register data. So once you have that generated, what's going to happen is you're going to have these folders and files appear. So yes, these files are generated. So if you click the core, source, and then main.c, this is where everything will be run from. So it looks quite intimidating, but majority of the stuff in here is comments. So these are all comments. These are all comments. And then the vast majority of this is comments. So whenever you start this, what's going to happen is your program will start here and it'll run all the way down until it gets to this while loop, and then this will loop forever. So just as well, I want to explain these comments. So we generated this code from this IOC file, and what happens is you go back and forth with the hardware team and make some changes, and sometimes you actually just need to change some values in this hello world.ioc file, and you need to regenerate. So it regenerates, and if you don't have the code in the right places, your code will get wiped out. So see, if you look here, user code begin and end. So I'm going to put in a variable in here, var equals 0. It should have been var, but whatever. And I'm going to put 1 outside. And then if I go and regenerate this code, what will happen is this will, if I'm remembering right, this will disappear, but this will stay. So if we go back in here, and if we regenerate the code, yes. Yeah, see, it disappears. So you need to, if you're adding any code, it needs to be within these user code bits. So there's user code begin includes, private type defs, defines, macros, and variables. What else? There's also function prototypes, private function prototypes, private user code, and then in the main there is stuff in here as well. So I'm going to create I don't actually need a variable in this, so it's just something to remember, keep in mind. So what I need to do is come down here, and in this user code begin bit down here, what I need to do is turn my LED on and off, and I need to add in the delay so I can see it as well. So what I need to do is look for, if I type in, so what I did to get that up there is Control Shift F, and then if you type in HAL GP and hit find, you should see this. So this just resets it this initializes the GPIO, and then this just resets it. So it says GPIO pin reset, which is basically setting it low, so it turns it off. So if I copy this and then scroll back up to my while loop and put that in there, and then if you control and click on this, it'll show you there's reset and set. So reset is off, set is on. So if we just take a look at this function, HAL GPIO write pin. So what this looks for is the port that it's on and the pin. So if we go back in here, this is PA5. So there are, I believe there are 4 ports, maybe only 3 in this. So there's the A port, the B port, and the C port, and then each of those has their own pins. So this is port A, pin 5. So if I go back to my main, this has already set this up for me, but if I go and look at this green LED GPIO port, so control click, it's set at the GPIO A, and then the pin is GPIO pin 5. So that's what this is really handy for, this IOC file. What it does is it generates all this for you, so that like whenever you're getting up and running quickly, this just is ready to go. So I'm going to turn it on, the LED, and then add a delay. So it's HAL underscore capital D and then delay and your brackets, and then you can put in whatever delay you want. I'm going to put in 100 milliseconds. So this is generally in milliseconds. So 1000 milliseconds is 1 second, and then that's 100 milliseconds. There is also a microseconds function, but we don't need that today. So I'm just going to copy this as well, put it in here, copy this, put this in. So this will blink on and off every 200 milliseconds. So 200 because it's on for 100 milliseconds and off for 100 milliseconds. So what I'm doing is writing to the GPIO, the green LED GPIO port and the green LED pin, high, delaying for 100 milliseconds, and then writing to the same port and pin just low, and then waiting for 100 milliseconds, and then this will do this forever. So with all that done, what you need to do is Control S to save it and then build it. So the build button is just this button here, or you can just hit the debug icon straight away, but we'll just do this for now, build project. So whenever you build it, it'll come down here and it'll do a few things first, and what it's basically doing is using makefiles to build your project and create an executable file. So it's basically this hello world blink.elf file, and then this is like the memory usage. I can't remember what each of these means, but this is fundamentally what the memory usage is of your elf file. So yeah, once that's done, what you can do is go to this debug bit and click the wee drop down arrow, and then debug as, okay, we don't have a configuration, so we need to go to debug configurations, and then come down to this STM32 C++ application, click that, and actually double click it. Yeah, double click it, and then if you come over to debugger, click this and hit scan, it should find your ST link, and I'll just pop in a serial number in here. There you go, and then hit apply and debug, and what this will do is this will flash your board with the code and then put it into a debug state ready for debugging. So it'll ask me to switch to debug mode, which is just a wee window over here. So you can see this is the, whenever you're writing your code, you'll be on this window. Whenever you're changing the IOC file, you'll be on this window. And whenever you're debugging, you'll be on this style of window, and it just rearranges everything and gives you different outputs. So over here you can watch variables, see where your breakpoints are, see what's in your general registers. So if you're into your assembly, this is of interest to you. And I can't remember what expressions does. I think it, yeah, I can't remember. I only ever use this watch variables bit. Doesn't really matter for now. Anyway, so we're in debug, and what this does is it starts the program and halts it here. So before it even begins, it just stops here. And what we can then do is come down here. I'll just play it first and show you the code, or show you a an overlay of the board flashing. So if I do that, whenever it's in debug mode, you'll see that green and red LED flashing, and then if you hit play, it'll start flashing, and if you come over here and hit pause, it'll stop at whatever state it's on. Now it won't stop on this code, it'll stop somewhere else where it's down in, but if you just hit play again, it'll begin again. And what we can then do is, I'm trying to do this with my hand and record at the same time. So if you come down here and hit a breakpoint, it'll stop here, and what we can do is also hit a breakpoint there. So this is before it switches it on, and this is before it switches it off. So if I hit play, it'll come down and hit this breakpoint. I keep the LED on, and if we hit play again, it'll turn the LED off. And then what we can do is to remove these breakpoints, double click, and hit play, and it'll keep running. And then hopefully in your setup you should have the same thing going on, and then what you can do is play about with these and change these. So if you can change these delays, and then what you need to do is, if you change any code here, you can just stop debugging, go back in here, rebuild it, and begin debugging again. So if you just hit debug, it should just do it. If it doesn't, hit this down arrow, debug as yeah, you should only need to click this, and it should build it, flash it, and debug it again, and then it should have your altered code running on it if you've changed the delays or whatever. So that's basically how you get started with the STM32 Cube IDE and get your board up and running, debugging and flashing an LED. So the reason we do the flashing LED and do Hello World isn't because it's just convention. For me, my understanding of why it's done is so that it can check that everything's up and running okay, and your board's working okay, and your debug environment is working okay, things like that. So with that being said, I'm gonna go and chill out for the rest of the day. Keep an eye out for the next one. It might be up, it might not, but yeah, that's me. Okay, bye.